And so now we're going to look at a quotient rule for exponents. Luckily, we have seen that multiplication and division are related. And our quotient rule for exponents is going to be related also. So we're going to just start right off with the rule. If I have a base divided by the same base but to a different power, our solution is going to be, or our new quantity, is going to be the difference. So as we see that addition has an inverse, which is subtraction, and multiplication has an inverse that is division, with exponents these two come together. And when we divide by a power, with the same base, we can subtract. And so we'll look at an example of that. If I have x to the fifth over x squared, that's the same as x to the 5 minus 2, because I'm taking this, goes here, this part's coming, snaking around here and coming here. And so it takes the place of our m and n in the original. It gives us x cubed. And so this lets us express the ability to divide powers. And this can also get used in combination with other. So I can have a to the fourth. Let me change my colors up here. Sorry about that. So that we can keep these parts separate. I'll say a to the fourth times b cubed over a times b. We'll make that times a over b. There's a couple different ways you can do this. What I like to do is, because this is a multiplication between two fractions, I'll multiply my tops. So I'll put a to the fourth times a. And that's taking this term here, bringing it over to here, and this term here and bringing it here. I still have my b to the third, which comes from right here. So there's my new numerator, a to the fourth times a times b to the third. Well, I can do the same thing here. I'm going to have a times b. And that's these two terms here. And then this term here gets multiplied here. So I have upstairs a product rule of a to the fourth plus 1 times b to the third over a times b to the 1 plus 1. Simplifying that, upstairs I have a to the fifth, b to the third over a, b to the second. Now my quotient rule says I can subtract what I have downstairs from what I have upstairs. So a to the fifth minus 1 times b to the third minus 2. That is equal to a to the fourth times b to the first. And so we'd write it a fourth b. So these rules can combine, but when we have a division, we use a subtraction. And when we have a multiplication, we use an addition. I look at exponent and power rules as kind of like you're on a ladder, and you're looking at the rung below you. So you're multiplying things together, while the rung below you in your order of operations is additions. We'll practice these, and we'll be able to get this pattern down.